and finally we can generate a response. It's not very system will load only code required for this single controller. Modern tools in PHP will help us. Most of the frameworks provides deferred loading, lazy loading factories, and PHP provides us op cache, which simplifies this loading a bit more. If you want to jump further and speed up your application on a bit higher level, you're going to jump to the caching. Caching is obviously more complicated approach because you have to worry about caching validations, you have to worry about warm up, but that's essentially, let's say, how Symfony built and how many other frameworks built. This approach allows you to do some calculations once and reuse them on the following requests. Your code still loaded in memory just once and then destroyed after request is over. So if you will take a look on the request flow, our entry point, or when request comes to application, located outside or within the initialization endpoint. So we get a request, it's part of the state variables like get post files. We load our code, initiate composer, do all the work, generate response, and then, well, we wipe everything away. This approach has pros and cons. The pros that it's very simple. You don't need to worry about memory leaks. You don't need to worry about race conditions or deadlocks, which are more common for sync models. You don't need to worry about memory at all because it's being wiped out. But at the same time, you cannot use this memory very well because your RAM does not exist between requests. And which is worse, on every request, we perform a lot of useless work to just load our libraries, parse config files, create connections over and over again. With preloading, it's a bit more simple. I mean, fast, but still problematic. The setup on a server is usually like that. You have an Nginx, which is your ingress server. It serves part of the static files and then defers some of the requests to the PHP FPM process manager, which creates PHP process or reuse it from the pool. And after request, it performs a full cleanup. In some cases, you can perform partial cleanup, just wipe the memory, but the result on performance are going to be very similar. So, well, what can we do? What can we do to jump even further after using approaches like lazy loading, like caching? Well, number one, we can actually rely on the functions provided by the language itself, which is obviously opcache. I hope no one is running PHP applications on production without opcache turning on, and obviously without xdebug turning off. We can wait, I mean, or now expect to have preloading, which helps us to bootload some of the libraries on the language level. It's a good tool, has its problems, but overall is going to give you some performance improvements. Or we can just wait for PHP 8, get the cheat, and hope it's going to solve our problems. Unfortunately, in real-world applications, you are not going to get that massive performance boost, but in some typical use cases, you could. We can do a bit more radical approach. We can just shift to different stack or different runtime. As you probably know, there is a number of alternative PHP runtimes so far. There is HHVM from Facebook. There is KPHP from Russian Vkontakte. There is PHP, which compiles PHP to C#. Weird tool, but works. Or we can just say, okay, let's just rewrite everything to different language. We got bored of PHP, but we own PHP conference, so we're not going to do that. Well, there is another approach. Instead of doing something, we can completely turn the table around and see how we can change the application flow. So we can actually get a lot of momentum by eliminating code bootloading on every request. This useless operations. We can use our RAM as it's intended to be used, cache something between requests without relying on file cache or mem cache, and we can eliminate process destruction, which is fairly complicated and fairly resource expensive thing. So how it should be done? Well, it should be done by daemonizing your application. And the process of doing that is made by introducing so-called main loop or primary loop inside your application. Essentially, be moving the entry point and exit point from the initialization inside your application. So we can bootload it, create libraries, and then we can accept requests over and over and over again. By doing this approach, we can immediately reduce the server load because we no longer parse PHP files on every request. We're going to spend a bit more memory because our workers will stay in memory with all the code bootloaded. But at the same time, we can get a fairly noticeable boost by using already open connections because we no longer need to close it. We don't need to close database connections. We don't need to close gRPC connections and so far. If you want to get even more, we can perform a number of optimizations for our code, and all of these optimizations focused on the runtime only. Because our initialization and code loading only happened once, essentially we can treat it as free bootstrapping. So we can move some of the caching, some of the user libraries from the main loop to the initialization phase. Usually it's some template pre-calculations, routing, compiling, ORM templates, ORM schemas, and etc. We're trying to basically make our runtime to be very, very thin and very, very fast. Even by that, we're going to get performance benefits, but it's going to have an interesting paradox compared to typical applications. So if you will take a look on the daemonized application on the left and classic application on the right, they similar but not so. And the interesting thing that the typical application will execute single request faster than daemonized, because in daemonized we essentially made our bootload phase a bit wider, a bit larger in order to save on runtime, but it still creates an overhead for the single request. However, all the following requests will be performed much, much, much faster in the daemonized application. We don't need to perform this work over and over again. Obviously, free cheese can be only in a mousetrap, so there is a number of things which we need to worry about when doing applications like that. Number one, and the most obvious one, is memory leaks. We can solve this problem two ways. Well, number one, write code properly. Don't use libraries which you don't trust, and just write solid code. Usually doesn't leak. Things which leak are typically caused by either very old-fashioned approaches, global variables, or something which in a modern PHP world are not very welcome. Option number two, use proactive monitoring. You can actually check how much memory a worker consumes, and if you'll see that memory drifts, you can do some actions. You can restart the worker, you can create new worker pool, or maybe you can just sit and debug until memory leaks will stop happening. Second problem, which actually much worse than memory leaking, is state pollution. So this problem is very common for the older type of frameworks and older type of applications, and it usually caused by the code which does not know that it's going to be invoked multiple times within the process lifecycle. Great example. Okay, let's use our current user, put it into global variable up user, and forget about it. Well, what's going to happen on the next user request, even if it's someone else, there's a chance that application will open the user profile from someone else. All your sessions might not be closed, and you might leak your card details and your checkout to someone else. How to solve it? Well, you need to manage your request context properly. So you need to do it probably on the application level, domain level, or you can use container and just reset it between requests. And the last problem, which is just very painful to deal with once you have it, is resource locking. There is two types of problems. Number one is that connections will die, essentially. Any connection to database which you have will be randomly closed, just You can't avoid that. It can be firewall, maybe database got rebooted, maybe your port was recreated. So what you need to do, you need to either implement proper TTL to close your worker periodically, or you need to write your code properly. So every time your PDO level or your database detects that connection drop, it automatically recreates it. Secondary, when you open files in exclusive mode or any other mode, they will still be open for the duration of the process lifetime. So open files for log writing in exclusive mode might break your system because multiple workers or multiple threads won't be able to access this file for a while. So once we identified that we have such model, it has some problems, but it has some benefits. Uh, Maybe let's see how we can implement it. So in implementing long-living model, there is two primary approaches, which for most of you are going to be already familiar with. Uh, One of the probably common approach is non-blocking. In this case, we are serving requests directly from the application. So essentially our server and application is a single tool. We gain a lot of additional performance because we don't have any additional overhead, and we can use modern tools like promises, streams, WebSockets, and etc. The problem with such approach is that if you're not using correct library, you might have a problem. Typically, it's related to the blocking resources. So if you use a classic PDO, well, you have to forget about it because you need to use some database solution which is built based on promises and can work in a proper event loop. Another problem is that any errors in your application might break your server completely. So essentially, the code in your error may completely stop your application from working. And typically for developers who got trained on the classic frameworks, on the classic tutorials, this approach a bit more complicated because it has a bit more syntax approaches which you need to remember, especially promises, especially yields, and etc. You can implement that using a number of existing solutions. There is React PHP, there is Woolly, there is AMP PHP, Workerman. There's a ton of them. Some of them written on PHP directly, some of them written on C++. A separate word about Swooly, because a lot of people ask me what's the difference between RoadRunner and Swooly. The Swooly is a coroutine library for PHP. It's very powerful. We respect it a lot. It's probably one of the fastest way how we can run a PHP application. The problem is it was created as a library, not as framework. So essentially, it brings async approaches to the PHP, while we want to bring PHP to the async world from a bit different angle and embed it as a language within different business flows. Plus, it didn't work for Windows when we started. I hope it do now, but it's a small problem for us. Uh, Alternative to non-blocking approach, there is different thing, which blocking, surprisingly. In this approach, instead of having a main loop and multiple threads or coroutines inside your application, you actually have multiple workers, and you balance requests between them. The beauty about this approach is that your application still works in a blocking mode, which means you can use any of the existing code you already have, any PDO libraries, any ORMs, anything which you're already familiar with, and it's just going to work. It still might have memory leaks. It's a bit easy to prevent. It typically does not have deadlocks or race conditions because all the code is isolated in a separate worker. But the problem is because it's a separate workers, someone needs to send requests to them, someone needs to send data and receive it from them, which has to be done between two processes, which is IPC, which is not free. So we're going to review how we can solve that on a bit later slide. The existing solution for this approach is PHP PM. Well, besides RoadRunner itself, this solution written on React PHP on PHP itself, and it's on the market for a while. The only problem is they still claim not to be fully stable. They still claim they have potential memory leaks on a server level, and based on our benchmarks, it was pretty slow, which does not make us happy about putting it on production, especially non-reliability part. So let's jump to the approach when you'll try to create a system which can run PHP code in a blocking mode. So we can use existing application, existing code, without dealing with promises, yields, and let's try to make it fast. So we need to create app server or application server, which is a very popular tool for almost any other language like Python or Java, but not so for PHP. So before we're going to jump, we need to define what we want to get. And we want to get maximum compatibility with existing frameworks. We want to separate the process for app server and PHP so we can upgrade and update and control them separately. We also want to have a very high performance, good error handling, good fault tolerance system. We also want to treat our PHP more than just thing which handles some HTTP request, more than some business unit block which you can embed in any data pipeline, queue, gRPC, Kafka, whatever. And it must work anywhere. And it needs to be upgraded very easily and has a huge number of extensions from existing ecosystems. So as you probably guessed, we are going to be creating RoadRunner on a Golang, which actually like very, very well suitable for this type of work. So I already spoiled the name multiple times, and the app server which we're going to be creating in today's presentation will be called RoadRunner. It's already on production, used by many people, and used by us to drive real world enterprise projects. So if you want to create an application server from scratch, what do we need? We need four main pillars. Number one is, well, we need some way to communicate between processes or create inter-process communication um, method of exchange between Golang and PHP. We need to manage our workers. We need to make sure they're not dying, or if they're dying gracefully, that memory does not leak, that our state controlled correctly. We need to create a load balancer, which is going to be utilizing workers effectively, but at the same time, not letting system, let's say, send two requests to the same worker at the same time. And we need to implement the actual HTTP stack, which is going to be receiving requests, sending them to PHP, and moving back. Well, first part is IPC, and we have multiple options how we can do that. Number one, we can embed PHP into the Golang itself, which kind of contradicts to one of the approaches, one of the things by separating the domain layers, but we still can do that. It's not that easy because you'll have to compile PHP separately. You'll need to embed it. You need to make all the bindings for C libraries, but there is solutions for that. You can play with that. It's not production ready, more like experimental toy, but it is possible. Second approach is to use shared memory, essentially have a common memory pool between PHP and Golang processes. Most likely, this is going to be very, very high performance approach if you'll deal with memory mapping. But at the same time, it is very OS specific and it does require a lot of configuration to make it work properly and reliably. For right now, we are not jumping to this approach. Instead, we're trying to do KISS or keep it simple, stupid. Let's try to make something super simple, super reliable, and hopefully not so slow. So what are we going to be doing? We're going to be creating a transport level protocol, or the thing which can communicate with data with worker using pipes, unit sockets, or TCP sockets. It must be that simple. It must not require any tools on PHP and to implement no extensions, no libraries, which means we can run it in every environment for almost any PHP version. It should have very small overhead and work as half duplex or full duplex, passing data in both directions, and it needs to include some sort of error correction mechanism in it. Well, what we come up in version 2, which we not so like right now, we want to improve it, is the following frame structure. We have the header of 17 byte size, which contains the package type, contains its size in little endian and big endian. We use it to compare if there are any errors happened during transfer. Not very optimal approach, but still works perfectly. We have 8 control flags and a huge room for the body. It's very simple. It's very straightforward. So to implement that on a Golang, we can use all the SPL libraries like IO, .NET library for sockets, and just default encoding binary to work with our frames. On PHP, we can use default functions pack and pack, and embedded extensions, streams, and sockets to work with communication. The side effect of such implementation is that we also built the RPC bridge, which allows us to create a service in Golang, um, any service, any wrapper for almost any Golang library, and then we can invoke it from PHP as RPC. This approach works way faster than just calling it by REST endpoint or even gRPC. It has almost no overhead, just message packing and well pipes transferring. So you're basically bottlenecking on the system level. But this is going to give us a lot of interesting abilities in the future slides. How can we actually communicate from a worker to the process? So now let's jump to the worker. And if you want to write an process manager, we first need to have an abstraction to represent our PHP process. This is fairly straightforward. What we're going to do, we're going to have a worker level mutex, which only allow us to pass one request at a time and wait for its completion. We're going to have a number of real-time counters, like how many requests it processed, was it created, what is the memory status is. And in addition to that, we are going to have the real-time buffer for the errors. So we're going to be collecting all the information from STD error and sending it back to the user terminal or some log solution just to see what's happening inside our worker. We also need some way to create these workers, and this is part of the process manager, which is called factory. It's very straightforward. We just get, well, we want a worker, we create a pipe, we assign a worker to it, and here we go, it works well. The only issue is that when we create workers via sockets or Unix sockets, because in this case, we need to also perform a PIT handshake to identify which worker connected back to us. We want to create 10 workers, they all connect back to the port. So we send the frames between them to understand which one of them corresponds to which process. Works well. Um, well, next part is the part which actually the core of almost any process, almost any like web server or app server, which is load balancer. This thing responsible for the effective delegation of the work to one of the workers in your system. And we can implement it by using LIFO stack in the form of buffer channel in Golang. If someone not familiar, this is a way how you can actually communicate between a sync or like coroutines in Golang. We're going to put all the workers in the stack. When request comes, we're going to take one worker from the stack, send its request, and wait for request completion. If we cannot allocate the worker, they're all busy, they're all doing something, we can just send timeout to the user or just keep requests sitting in internal queue. So we can basically aggregate a number of requests when we have a peak loads. When worker succeeds, we can send requests back to the user, obviously, and then we can return worker back to our pool, which makes it available for the next request right away. In case of error, we're going to send error to user, and then depending on type of the error, we can either destruct worker and ask our factory to replace it, or we can just move it back. Maybe it was just a soft error like validation or something like that. So as a result, we have the following sync. It has like three main loops: get worker, get response, return worker. It works very fast. Essentially, we need about 200 nanoseconds to allocate PHP process for the request, and it has embedded system for automated recovery. So in case of worker dies, system can go and replace it with a new version. In addition to that, we're going to implement the subsystem for the proactive monitoring. We're going to be checking how much memory worker consumes, how long it processes a request, how long it sits without request. We need all these metrics usually for older applications, which tend to memory leak, because sometimes it's just cheaper to restart worker every 100 iterations than spend weeks finding the memory leak. In new applications we create, or like architectures which know and are aware about context logs, you don't need that. You can just remove the proactive monitoring and just, well, PHP doesn't need to leak, so it should work well. And the last part of our application server now is a web server as well, is HTTP stack. The less exciting part, because accidentally the Golang HTTP layer and PSR7, which we're going to use as transport, are very similar. So the only thing we need to do is a GET request from Golang, map it to PSR7, pass to worker, unpack and process it, and well, send response back. To implement it, we can use fully SPL libraries on Golang. It's HTTPS, HTTP2 libraries. It has a ton of extensions, a ton of middleware. And on PHP, we are going to use framework agnostic PSR7 library, or actually not library, more like a standard, which is immutable, which is great for long-living applications. You don't have easy ability to kind of store a request in a global variable. And again, it has a ton of extensions and a ton of middleware. Once we assemble it all, combine all this process manager, HTTP stack, we can now launch our app server. To do that, we simply have to put a config file in a root of our project, download the binary file, which is just single file, no extensions, configure which worker to run, which port to use, how many workers to use, and here we go. Is going to work like that. On PHP end, we need to create a primary loop. This loop is based on PSR7 implementation. It's PSR 15 and 17 compatible, so you can use any router, any middleware, almost anything from PSR world. What we do, we have a main loop which consumes request, processes it with our application. In our case, just doing hello world, and then it sends response back to the browser. That's it. Now, what we also got by doing application server in Golang, we got the architecture which allows us to build it customly for different projects. So essentially, we have ability to customize our PHP application from infrastructure level and introduce new tools and new approaches to our development stack. So, well, let's take a look on use cases. And first, what do we have? What we have from the kind of overall structure, we have a modular structure, which allows us to invoke any PHP worker or worker pool from any Golang process. It can work as standalone library. It can pass any arbitrary binary payload to and from PHP, and we can communicate from PHP to Golang using GoRich RPC protocol. First, what we can do and what we actually do on a production, we can implement middleware on Golang. So in our case, we implement a GWT middleware on Golang application. You can do any token-based with database or Redis as a backend. And the beauty of such implementation is that it can work on a very, very high scale. You can implement additional modules like circuit breaker or rate limiters, but essentially, if request is not valid, it is not even hitting the PHP application. So you can cut off all the bad requests before loading your server by using Golang part of your logic. Secondly, what we can do, we can implement monitoring middleware. We can capture how long each request processing takes, send it to Prometheus, do some work, maybe implement some real-time monitoring, profiling, or something like that. Actually, from version 1.4, we have monitoring embedded, so you can have Prometheus out of the box for your applications. It's great to see different charts and metrics which are application specific. We can do something a bit more complicated. We can actually introduce a third-party or external solution to aggregate logs and profile metrics. Or what we did, we tested the RoadRunner with XFProf. So we activated XFProf in requests for the PHP workers. And this way you can actually keep collecting profile stats and logs on production and send them to some external database for late analysis. So you can do that because you can intercept the request, add additional tags through the PSR7 attributes, and then handle it on PHP level. You can do something a bit more funky, let's say, and you can actually do the routing on Golang as well. You can implement part of the application, let's say parts which are very, very performance intense, or parts which are related to like long streaming or long pooling or something like that. You can do these parts on Golang. You can just write a module, connect it as part of the HTTP layer to HTTP stack in RoadRunner, compile it, and here we go. Part of the request will go to Golang, part of the request will go to PHP within single binary file. This is how we actually implemented the WebSocket extensions by actually intercepting some of the requests and forwarding them to WebSocket library, which is, well, here. That's how it's typically looked. You just forward some of the requests to WebSocket, and if you want to publish something to that, you actually do that via Gorage RPC. It goes to PubSub broker and then to WebSocket. This solution is public. You can actually use it for your own applications. It does not require any external Node.js server, any Redis. It can work out of the box. And if you want to scale it horizontally, you can just connect PubSub broker like Redis, and it's going to work from multiple nodes out of the box. We use it to create real-time dashboards and stats for our applications. What else can we do? Well, because RoadRunner has full control on the PHP process lifecycle, or any application server has full control, you can actually control environment variables as well. So what can we do? We can actually inject some variable provider like console or etcd to our system. And on a worker startup, we can request environment variables from it instead of looking to .env file. Such approach is very useful when you need to create a large distributed applications and you need to coordinate configurations for multiple environments. It simplifies deployment a lot. What we want to do next, we actually want to do the code replacement as well. So we want to be able to deploy the updates for our applications with a single button, which sends zip archive to RoadRunner, is unpacked, tested, and then makes an atomic switch on the runtime. You can also do something more funny. You can embed some a bit more complicated libraries to your flows, not just HTTP specific. For example, on our documentation website, we use the library which called Believe Search. This is Golang full text library with text stemming and support for multiple languages. Essentially what we have a mini version of Elasticsearch without any third-party database or third-party solution, which we can use to index our texts, our documentation, and then perform search on it. You can open on a website and you can try to type something in a search, and you'll see how quickly it will respond to you. No databases, no containers, just straight out of the box binary file with NoSQL database, which is BoldDB. One of the things which we also tested is why we just can't get rid of the HTTP stack altogether and start communicating with worker pool directly. So what we did, we actually used Amazon Lambda runtime, and we connected our system to that. And as a result, well, we got a Lambda workers. We now can execute things in serverless environment. It works very easy. I would say you still have to create obviously custom PHP runtime. But the beauty about this solution is that because of the worker stays in memory for long, Lambda function stays in memory for long too, especially 15 minutes. So the first request will bootload your code, and then it will stay in a warm-up state, ready to accept all the following requests. So this makes these Lambda points to be very, very fast. In our test, we managed to achieve half millisecond response for the tip just hello world echo on Amazon. We can do more complicated things. We can actually replace Lambda part with gRPC part, which what we did in PHP gRPC. And now you can have a gRPC server for PHP. This server is going to publish, obviously, the port, manage all the security, manage TSL, long keep alive connections, and is going to work as a simple proxy for PHP workers by sending them binary protobuf payload. PHP will unpack it using the default extension. Here we go. You have the gRPC server. We also included a number of tools for the code generation, so you can just use a proto file and generate your classes in your code based on that. You can also have both of the services within one application and just forward request to one or another when needed. We use this tool a lot on production, especially for the sync communication between our microservices. Another thing which we use a lot and which we're kind of proud a bit about, which is QServer. So what we do here, we manage all the communication with brokers, MQPAL, Amazon SQS, Beanstalk, or in memory on a Golang part. this gives us ability to actually control the reconnect. So if connection drops, we can have like a backup strategy, reconnections. We can have prefetch strategy. We can do pause on runtime without doing any crazy um, like supervision configuration. Basically, all the heavy lifting, all the libraries done on Golang, PHP in this case simply handles the incoming task request. This allows us to do multiple things. Number one, we can create applications which locally work with queue in memory, with no brokers, with no Docker, just out of the box, install and it's going to work. And on production, we can switch it to, let's say, RabbitMQ using a simple configuration line. This allows us to publish and consume work as from Golang, as from PHP, which is usable when you want to do some kind of batch processing or something else. One of the things which we do now in like next probably a few months, we want to do the thing which even more complicated than that. We want to create a distributed workflow engine which is going to treat our PHP code as the set of independent business logic blocks and then coordinate requests with them. We have official coordination with Temporal.io, or maybe you guys hear it Uber Cadence authors, and since they provide an official Golang SDK for to create workflows like that, we have an ability to implement this SDK fairly easily and essentially be able to write sagas, workflows, subscription flows, or distribute cron jobs in PHP natively through the RoadRunner. So what do we have at the end? Well, we have the system which allows us to create two separate domain levels effectively. The PHP layer, as we comfortable with, helps us to create a very rigid business logic and API. All the ORMs, all the templating, all the JSON parsing, everything happens in PHP. That's what we've been using for last 20 years. While all the concurrent logic, complex algorithms, infrastructure, monitoring, managing queues, brokers, and maybe some task orchestration happens on Golang, which suits better for that. We are not mixing them, but we are dividing them and letting them do what they do effectively uh, for each other, let's say. Uh, we created this tool about 2 years ago, I would say. Since then, we used it extensively on production. We actually no longer use PHP FM at all. What we got on average 4 times lower latency response. We use real world applications, not synthetics, so we still have a bunch of PHP code. However, we completely eliminated 502 errors on the peak loads, which typically had to hang out on PHP FPM level, and then we had to spend a bunch of time trying to figure out optimal configurations and options. We have some applications which sits in memory for more than 4, maybe 6 months by now without rebooting. There's no memory leaks. PHP does not memory leak if you don't want PHP to memory leak. So that's good. And we effectively utilize all the open connections. We can keep talking to database without reopening it in every request. We can reuse and keep alive for microservice communication, gRPC, and etc. This whole thing runs in Docker, in Alpine, and we run it on Kubernetes cluster. There has been independent benchmark. I have to apologize. This benchmark did not include Fully. It was done not by us. It compared Nginx, PHP PM, Nginx Unit, and React PHP. In very high load environments, RoadRunner won on the performance. I will spoil you. Fully will be RoadRunner easily. This is C++ solution which does not have IPC overhead. You can check the framework benchmarks website to see um, what the numbers are, but for a very light like Hello World application, Suli might be 4 times faster. For more real world, like a Symfony-like application, it might be like 30% faster. So it all depends on your payload. Performance fast is just a kind of side effect, but still nice to have. What was important for us is availability. So from all the requests, we did not lose or broke any request, while React PHP and FPM actually did. So some of them failed. And well, back to stats. So we publish application under MIT license. It's free to use. It's free to modify on a GitHub in September 2018. Since then, we have around 2,000 downloads. It grows well. So we have a number of people who helps us to improve this thing. And more importantly, it help a number of people who helps us to write integrations. So far, we have integrations with almost any major framework on the market. We have official integrations for Laravel, if you want to play with that. And community integrations for Symfony, UE. We have our own framework, which embeds RoadRunner on core level, Cake, PHP, and Slim. So why do you need application servers, or especially RoadRunner, in your application? Well, number one, if you want to speed up your application a lot, and if you're not using Swooly already, if you want to control PHP lifecycle, if you want to treat PHP more than just let's just do some HTTP request, if you want to use it, let's say, for batch processing Kafka jobs, if you want to use it for some streaming activities, if you want to use it for business logic generation, etc., this tool will help you to treat it like that and write your core logic or like your infrastructure logic on Golang while using PHP to do all the heavy lifting on the business side. When it's just not enough to have PHP. There's been cases when we spent weeks trying to configure some leaky or crazy library on PHP just to generate correct Excel file or PDF file. In many cases, you might find a library on Golang which already do that and do that much better, either by having bindings to C or either just being Golang. For example, what we managed to do, we managed to embed Tor server and Tor client to RoadRunner and mock all the PHP code under it. Doing that in PHP will be unlikely because you'll have to do a lot of heavy lifting and a lot of work with like low-level language constructions. You have FFI now, but this works from a bit different direction. Or maybe you just want to build something crazy. So it will work in this case as well. Thank you for your attention. That's been kind of a light dive into RoadRunner. You can find the links from this presentation. I hope is going to be sent to you as well. And there is a number of publications which you can read about how people have been using it. Thank you for your attention.
谢谢，谢谢 ，Thank you. Okay, now let me ask the audience online if they got some questions. 线上的朋友们，就是大家有问题吗？如果有的话，可以在 slide 大度上面。那因为我现在是没有看到啊。好哦，那如果就是后续有问题的话，就是你们可以在 slide 大度上面问。那我们可以把就是那个有一个问题。OK，Hey, there is someone asking a question. He said that does RoadRunner just replace Nginx plus PHP FPM, or it make PHP become a Go plugin? What's the benefit of integrate Golang and PHP?
Okay. The benefit of integrating Golang and PHP that there is a number of business flows or things which you simply cannot do in PHP well. As I mentioned, like gRPC queue, you can implement it, but it's going to be very, very hacky. Doing the same thing in Golang will be much easier and much faster and much more stable, while it's also going to take you less time to implement. So essentially, if you don't want to have a full jump to different language, you can just use parts of this language to do your job well. So we found that just simple example queue, doing them in Golang is much, much easier and well, just works everywhere. So I would say that it's just more flexible and more reliable environment to run when you delegate some of the work to different stack. And answering the first part of the questions, yes, it can fully replace Nginx and PHP FPM altogether. It can set up static files as well.
OK，那还有其他问题吗？好 ，OK，Thank you very much, Anton. Thank you.
Thank you.
OK, there's no more question. Thank you very much. See you then. 拜拜。